Hello, everybody. My name is Ibrahim Babikeshi. I will be solving some question on EG 824 today. So, the problem I'll be solving is going to be based on optimization, and optimization can be solved using two methods. So, we have the graphical method and we have the simplex method. So, I would just like to solve a question that has to do with the simplex method. So I'll go straight into the question right away. So, so it's going to be like an example question. Let me see if I can write it here on the board. So we have, so this is AUG 824. So what we are doing is, so we are solving with simplex method. Okay, fine. So we are going to pick an example, which is going to be an example. So what's the example going to be about? So it's going to be a maximization problem. So maximization problem of z equals to 2x plus 3y subject to 3x plus 4y less than or equals to 18, right? So we have another, so that's the first set of constraint. So the other constraint would be 2x plus, here it is a plus 5y less than or equals to 19. So we search and we have x and y greater than or equals to 0. So less than or equals to means that this is the, so these are the constraint here. So that's the constraint. So if you are to solve this, let me try to zoom, let me scroll down a bit. So if you are to solve this, we have to, so the solution is as this solution. So for us to solve this, we need to introduce what we call slack variables. So and I will explain why we're introducing the slack variables. So so for so the slack variables, so here we have, so with the constraint in the first place, we need to solve for, with the constraint we need to solve for when x equals to 0, what's the value of y with respect to the first constraint, the value of x and y when x equals to 0 and y equals to 0. What do we have? So what does that mean is, like, for example, if we introduce, to explain it clearer, we know 3x plus 4y is less than or equals to 18. And if 3x plus 4y is truly less than or equals to 18, something needs to be added for it to be equals to 18. Same goes for 2x plus 5y, which is less than or equals to 18, meaning that the composition of 2x plus 5y is intrinsically less than 19, but plus something will be equals to 19. So if we want to go by the equal sign, it means that, so going by the equal sign, let me pan this up a little bit. So I need to pan this up a little bit. So if that is done, let me pick my pen here. So if this is done, so it means that for that to be an equals to, so we need to have, no, we need to have 3x plus 4y plus something. Let's call it s1 to be equals to 18. So we need to also have 2 2x plus 5y plus something. Let's call it s2 to be equals to 19, right? So that makes that equals to that. So we have that. Then if we go back here, we can see this, but we also need to rewrite the first objective function, the objective function which is z equals to 2x plus 3y in terms of this. So if we come down here, if we come down here, if it comes down here a little bit, so it means that we can rewrite that in terms of, we can say this is, so if we take the objective function which is z equals to 2x plus 3y, we can rewrite it to be equals to, so we can rewrite it to say minus 2x plus 3y, no, minus 3y, sorry, let me clean that. So minus 3y, so minus 2x minus 3y plus z equals to 0, if you had to rewrite it. So I want it to be in the same format with that. So if I'm to clean that, so I can come around and clean this. So I can have this. So this becomes my three equations. So I can come here to say this is 1, this is 2, and I can say this is 3, right? So these are the three equations. So we need to set up our kind of like a feasible region with this. So what is feasible region? We have to ask ourselves what will be the value of s1 and s2 when x and y equals to 0. And as we can see, it becomes obvious from equation 1 if you go to this route. So here from equation 1, s1 equals to 0 when x equals to 0 and y equals to 0. From here, s2 equals to 19, sorry, it becomes 18 rather, sorry, so it becomes 18, so it becomes 19 here. So we already have the value for s1 and s2. Now that's sorted. So we already have value for x1 and s2, and we do know that when x is 0 and y is 0, z equals to what? Z equals to 0 also from this, from equation 3. Z equals to 0. So that's sorted. Now we need to generate like our own graphs. So graph in represent, like, I mean a table that is going to be able to use to sort out this. So what do we know now? What are the variables that we have? So we do have, so just to, let me pan this a little bit. So what are the variables that we have? So we need to declare variables. So what are the variables that we have? So we have x, y, s1, s2, then we have z. So that's that. Then what we do know, we have the constant at the other side. So let's say we have k, let's call it constants, but we might not put anything there. So k, then we also have to have another ratio variable called ratio, which we are going to use later on, called ratio. So, or R, whatever you want to call it. So it means that we always need to have a table that represents all these variables at any point in time. So a typical table would be, so since we have like x, y, and z, so that will be, we have three rows. So this, and this will be the columns. So basically this will be the columns. Then we have three rows. So where x, y, and z equals to three rows. So that's sorted. Now we can have a sample of what our row will look like. So we can say x, y, s1, S2, Z, the K, and the ratio. So if this is sorted, then we can have like a table like this. Don't mind my handwriting. So, right, let's sort it this way. Okay, good. Now, since we all agree that we're going to have three rows, so we have three rows. So what would the row look like? I think if we go back a little bit to our equation here, we can see the coefficient will be the coefficient of x, y, and S1 and S2 in each of these equations. So if we go that route, here the coefficient of x is 3, y is 4, S1 is 1, S2 is 0, and others. So if we go that route, since we are going to be having three rows, so let me demarcate them so that we'll have this. Then the last row will be this, this, and this. Okay, so the first coefficient here is 3. The other coefficient here is 4. If you check, this is 1, this is 0, then this is 0. So the constant here is 18. So we're going to talk about the ratio itself later on. This is 2, this is 5, this is 0, this is 1, 0, 19. Then on the z part, we have minus 2, minus 3, we have 0, 0, 1, 0. So for the ratio basically, so for us to compute the ratio, I need to introduce something also for the ratio to make sense. For the ratio to make sense, we need to find what we call like the the pivot row and the pivot column. So according to the rule, so rule number one, so we have, let me zoom this up a little bit. So we need to have a row. So row. So so rule number one. So, so we need to find the pivot row. So we need to find the pivot row and the pivot column. So we need to find the pivot column. So the pivot column equals to the list value in Z. That's for maximization. So if you are considering maximization, we have to look at Z and we have to factor out which of them is the least. The list here is minus 3. So, and since minus 3 belongs to column 2, so if you look at it this way, let's assume that this is column 1, C1, C2, C3, C4, C5, C6, right? Then this is C7. This is the last 7. So this is, let's say this is R1, row 1. No. Let's say this is row 1. For sake of clarity, row 2 and row 3. These are just variable declaration. That's not. So that those are the three major rows. So that's it. We now we can now so this so automatically so the pivot column is the C2 column. So and equals to so so this is equals to the C2 column. So with that we now know that is a pivot column. So we have to ask ourselves some certain questions. So for if that is that, then it means that we have to divide the value of the constant by the values of the ratio equals to k over the value in the pivot column. So value of the pivot column. So, and I explained that we are going for the least value here because we are talking about maximization. So, if that is so, it means that this ratio here is going to be 18 here divided by 4, which is because this is the pivot column, 19 over 5, 0 divided by minus 3. So, if we do that, so we're going to achieve this. This is going to be, no mind, this is going to be 18 over 4. This is going to be 19 over 5. This is going to be 0 divided by minus 3 is going to be 0. So that's that. So that's how we get this. So this is number one. So with this now, so there is I'm going to explain the what the general goal is for this. So there the general goal is we introduce S1 and S2 into the mix just to be able to balance the equation. And you can see we have x1 equals to 1, 0, 0, 1 as more like an a unit matrix here. So this is 1, 0, 0, 1. So that's a matrix, right? 2 by 2 matrix. So x is 1, S1 is 1, the first row, and the first row of S2 is second row here, which is S2 0, this 0, 1. So what we need to do is that we need to transform the coefficients, these four coefficients, this to look like this and this and this. So what we need to do is this. If this is C1, this is R11, R12, R21, R22. So to be equals to this. So what we need to do, so we have a goal, we have an agenda here. So what's the agenda? So let me explain what that is. So the goal is to have R11, R21, R12, R22 should be equals to 1001. So that's the goal. This is the goal. So this is the goal. So if this is the goal, we have to ask ourselves, how do we get closer to the goal? So we already know how. So we know this. So and we already know the pivots column, which is the C2. So we now have to ask ourselves, which is going to be the pivot row? So, and how do we know the pivot row and the pivot column? So we have to ask ourselves this. We have to compute this. 18 divided by 4 and 19 divided by 5. Which of them is the least? So which of them is the least? Why? Because we are dealing with maximization, so we have to always go with the least. So this is if you compute this, 19 divided by 5 equals to 5, 3.8. So equals to this is equals to 3.8, and 18 divided by 4, 4.5. This is 3.84.50. So but we have to consider the value between x and y rows, which is row 1 and row 2. So between these two, which one of them is least? Because these are the major ones that we have to consider. So here, this is least. So the ratio here is lesser. So because the ratio here is lesser, we have to go for this as the what? The pivot row. You can agree that 0 is also lesser, but 0 z, this is the z rule, so we are not going to consider it. So we have to consider between this and this. So that's it. So that's the pivot row. So now we now have our pivot row and the pivot column. So if we go back if we go back to that, so this is the pivot column already, and this is the pivot row. So this guy, this number is so critical and very important. So because now we need to transform 3425 to be equals to 1. So we need like a transformation relation to be able to make this 5 to be equals to 1. So for the transformation relation, we have to So I might have to sum up a bit. So we need a transformation relation. So we need a transformation. So we need a transformation relation to be able to do that. So that aside, so one of the best ways we can look at it is like we need the column of that where the 5 is, which is this R22 to be equals to 1. So we have to ask ourselves, how do we do that? For intrinsic transformation that has to do with the pivot row and the pivot column, so we can say R2, so we can say so we can say we can say R2 new equals to R2 old plus x R2. Do we even need to do this? We just need it to be equals to 1, so we don't even need to introduce another variable. We can just equate it to x. Here x should be here equals to. So let me clean this. Let me clean this. So what we need is for that to be equals to 1. So that here we can just come here to say R2 new equals to certain value, let's say x, r R2, current R2, which is the old R2, and we want it to be equals to what? 1. So what we do know is that the R2 old is 5, so x times 5 equals to 1. X equals to 1 over 5. So that's sorted now. We can now say the transformation relation we seek equals to 1 over 5, the R2 old that we know. So we will come here. So if this is the transformation relation that we have, if we come here, we need to use that transformation on this entire row, right? So if you do that on this row, we're going to have new set of variables for that. So if you do that, we're going to have so we're going to have r so we are going to have r21 equals to 2 over 5, r22 equals to 5 over 5, which is equals to 1, which we want. We can also say we can also say r31. I'm already using r223 to be equals to 0, 0 over 5, 0 times 1 over 5. Then we can say r24 to be equals to 1, so 1 over 5, r25 equals to 0 to be equals to 0. And we can also have which of with the last one, which is the ratio. We already have the ratio already, so we don't need the ratio at this point anymore because we've used the ratio to decide. So we don't need the ratio. We only use the ratio to decide all of this. So henceforth, we are going to keep the ratio out because we are not making decision based on pivot row and pivot column. So we are going to be considering 1, 2, 3, 4, 5, 6, just 6. So that's that. So so 1, 2, 3, 4, 5, 6. Okay. So on the k side, so with that k is going to be 19 over 5 times 1 over 5. So this is going to be r to 5 equals to 0. So then we know that the other one r26 equals to so r26 equals to oh we already computed So that said, we have to rewrite the table. So now, with this now we have the core variables x, y, s1, s2, z. So then we have the constant k, right? So I will just be very fast, not so much design because we have so many things to do. This, this. So, so the one is still as it is, which is going to be 3, 4, 1, 0, 0, and the k is still 18. Then the row 2, let me check just to be sure. 18, yes. So and so so this let me zoom this up a little bit. Okay, I think we are good. So that's that. Let me draw the column here. Another rows. So here we we have the transformation for we have the new transformed row, which based on that this is 2 over 5. This is now 1 like we wanted. This is now 0. This is now 1 over 5. So here this is 0. This is 19 over 5, right? So we still have the z column, right? Which we've not worked on, which is minus 2, minus 3, 0, 0, 1, 0. Well, this is good. This is good. So we have the pivot row. This is one like we wanted. So we need to build on that. And to build on that, we have to ask ourselves, what can we use this to transform? So we can use this to transform this and this to be equals to 0. And that's the goal. So the next task is now that we have our pivot index, so the pivot index in our row and our column, so which is this, we can use it to transform this and transform this. And how does that work? We already know what we want. We want this to be equals to 0 and we want this to be equals to 0. So we need transformations. So we need to ask ourselves, how do we transform this to be equals to 0? For row 2, for row 1, 1, we want R1, 2 to be equals to 0. For row 3, we need R3, 2 to be equals to 0, which is this. This to be 0, this should be 0. And for us to do this, we have to use this to make this equals to 0. So if this is the goal is to make this equals to 0, it means, and the value is 4, it means the goal, the the row itself, this is row 1, the final one equals to the current one, the current value, which is now, which is can be the old value eventually, minus something, let's say that is x, times the value of row 2, which we are using to transform it, should give us 0 because we want the value of this row 1 to be equals to 0 eventually. So if we look at it this way, it means this minus this must give us 0. And we do know the value of this, the current value, which is going to be the old value once we are done. So this, and we already know the value of this once we are done, which is going to be 0. Then it means that we can say r old minus x this equals to 0. So we can now say, I just want us to compute x. So x is now going to be r old. The old for row 1 is 4 minus x R1, which is times 1 equals to 0. So we can say x equals to 4 for this. So the transformation relation will now be this, right? So the transformation relation we look for here is going to be R1 equals to R1 old minus 4R2. So for this, we need to compute for this too. So for us to make, so this R3 here equals to R3 old minus something Y, right? R2 must give us 0 because we need it to be 0. But here is one thing we do have. So this is R3 old is minus 3 minus Y. Then R2 is 1, right? And everything must equals to 0. So we can say we can say this is y here. So y equals to minus 3. So if we go into the relation, so the transformation relation will now be according to this. So if we put y to be equals to minus 3, so r3 here, so we have r3 equals to r3 old plus, because y is now minus, now minus 3 for y, that's going to be plus r plus 3 r2. So that's the transformation for that, for this, and this is transformation for this that we're going to use next on it, such that we can now transform this to 0 and this to 0 eventually. So if you have to go by that, so I like to do the transformations together. So if we are doing the transformation together, we can now say, so we already know what we are using to transform, so we can just compute the values for the new rows, right? So we can just say, so we can just say, let me see if I can. So we can just say, so for row 1, so the values we are going to be having now is going to be, so for row 1 here we are going to be having, okay, we're going to be having, so R11, which is now going to be 3 minus 4 into brackets 2 over 5. So this gives us 3 minus 8 over 5, which is 15 minus 8 over 5, which is equals to 7 over 5. So this is R11. We can do R12, which is going to be 4 minus 4 into bracket 1, which is going to 0, which is what we want. We can decide to, zoom here. So let me see. So this R13 equals to, R13 is going to be 1 minus 4 into bracket 0, which is equals to 1. R14 equals to 0 minus 4 into bracket 1 over 5 equals to minus 4 over 5. So R15 equals to 0 minus 4 into bracket 0 equal to 0. R16 equals to 18 minus 4 into bracket 19 over 5, right? So this gives us 18 times 5, 5 times 8, 40. This is 90 5 minus 76 over 5. If I'm right, yes. And this is going to give us, so this is going to be, let me check this calculator wise, 19 times 4, 76, 18 times 5, 19 minus 76. So this is going to give us 14 over 5. So this is 14 over 5. So that's the transformation for row 1. Those will be the new values for row 1. We can zoom up and do the same for row 2. So for row 2, sorry, no, row 3 this time, because we already have our row 2 the way we wanted it. So this for row 3. So row 3 will now be, we already have the transformation relation, don't forget, which is R3 equals to R3 old plus 3R2. Okay, good. So with that, we can say R31 equals to, so R31 equals to, so if we do this, R3 would, this will be minus 2 minus, that this is plus now, plus 3 into bracket R2, 2 over 5. So this is minus 2 plus 6 over 5, 1. So this is 5. This is minus 10 minus 6 equals to minus 4 over 5. So R32, so R32 here is going to be minus 3 minus 3 into bracket 1, which is what we wanted, which is, no, plus, sorry, it's plus here, which is 0. So R33, so R33 is going to be 0 plus 3 to bracket 0 equals 0. R34 equals to, so 0 plus 3 into bracket 1 over 5 plus 3 over 5. So R35 equals to 1 minus plus 3 into bracket 0, 1. So R36 equals to 0 minus plus, sorry, 19 over 5. So this is 57 over 5, I guess. Right? I think we are good. So we now have the new values for both R1, for the new transformation of R01 and O3. So we need to slot that in and create a table for that. So if we decide to create a table for that, so we're going to need a new table. So this is X, Y, Z. No, sorry, we need X rather. So we need X1, and this is because we are dealing with 2 by 2 though. Okay, so this is, xy, xy, s1, s2. Then we need what? We need z. So we need z. Then we need the constant side, which is k. So that said, and remember we've already transformed it. So now that we've transformed it, so we already have our values. So we already have, this. So with this, we can just taking my time to explain everything so that it doesn't I don't get lost in the process. So with this, we already calculated for the value of x, y. So we can just come and fill in no particular order. This is minus 4 over 5. So R36 is here. This is 57 over 5. This is 1. This is 3 over 5, 0, 0. This is 3 over 5, 0, 0. So row 2 still remains row 2 like we already know, but we need to change row 1. Row 1 we need to fill out row 1. Row 1 is 7 over 5. So this is 7 over 5. Um, the second row column 0, 1 minus 4 over 5. So this is 0, 1 minus 7 over 5. Then what's the 0, 1 minus, no, it's minus 4 over 5, 0, 14 over 5, minus 4 over 5, 0, 14 over 5. So I think that's it. Just to be sure, let me clean this just to make it much cleaner. I rewrite it. So, so this, so let me fix this. So this is 4 over 5. Okay. Okay, this is minus 4 over 5, right? 0, 14 over 5. So let's put our row 2 as it is before because that's what we're using to transform. So column 2 and row 2, they are the transformation they are the pivots 1 column. So this is, I think this should be 2 over 5. This should be 1. Then this should be 0 because I'm also doing this indirectly. 0. Then this is 19 over 5 prior to now. So 19 over 5 already. So here we have. So we already achieved two of our goals, which is to transform this to 0, to transform this to 0. But the next goal we need to achieve is to transform this to 1, 0, and this also to 0. So we need to do like another set of intervention. That would be we need to recompute our ratio. So we need to so the goal 2 here is, so let me zoom this. So we need to recompute our ratio. So first of all, we already know that we are done with this column. So this column is cannot be used by us. So we need another intervention. So and that intervention will be the second iteration. So we need to introduce what we call the second iteration. So this is the second iteration. So we need to introduce the second iteration. And the second iteration is to like start this thing all over again, but with a different column because this column cannot be used again. We have been able to transform all others to 0. So we can't use that column again. So we already know by default, we might have to we can compute it, but we also know by default that the next column will be the column for x. But what we don't know basically is we don't know what the pivots row will be like. So we don't know that yet. But even by logic, we can also guess that it's going to be the other one, which is going to be the first row. But by logic wise, we can also say since we are working on so this now for the second iteration, so this column 1 becomes our main column. So this so, so let's run it to be legible. So So column C1 equals to what? Pivot column, because we already use C2 for our pivot column for the first iteration automatically. But what we don't know is this. We need to compute our ratio again. So I won't draw the table anymore. So what I will just do is I will just extend this table. So we need to compute ratio so as to decide which of the row will be our. So we need to compute a ratio. So for us to do that, we are going to come here and say, and how do we get our ratio? Remember, ratio equals to k over the value in the pivot column. So that's sorted. I think let me so that's sorted. We can find the value of our ratio. So the ratio will now be R17, I guess, which will be the last one, which will be the k, what is the value of k? 14 over 5, which is going to be 14 over 5. So 14 over 5. So divided by what is going to be divided by 7 over 5, which is equal to 14 over 5 times 5 over 7. So this equals to 2, coincidentally. So we can do R1, R27 equals to, so R27 we already know is going to be um, 19 over 5 already, divided by 2 over 5, which is going to be is it 19 over 5? Let's check. Okay, it is. So it is. So this is 19 over 5. So this is, so this 19 over 5 times 5 over 2 equals to 19 over 2. So that's what we have for the ratio. For the Z ratio, we can calculate it, but it doesn't really affect us at this point. 3Z equals to, so that is going to be 57, so 57 over 5, 57 over 5 divided by minus 4 over 5, right? So this is minus 57 over 4. So this is key. So we can have that as our ratio. We can add. What's important is between this, and this, we need to decide which one is least. And this is lesser. So this is lesser because we are considering maximization. So we go for it. We go for this because we're considering maximization. We have to go for that. We don't have much. We don't consider the z part, but we have to consider between the rows of x and the rows of y, which is the row 1 and row 2. So, those are the ones that have x1 and x2, so we are considering that. So that said, we now know that our pivot row is row 1 and our pivot column is also row 1. So that's sorted. So we can go back and see. So here, so we are going to go for this as our pivot row. So now that we know that, we can now ask ourselves, how do we transform that row into one? So we need, sorry, let me try to maximize this. I think I said, So, so one thing we need to do is we need to make R11 equals to 1. So R11 needs to be 1. So for it to be 1, we already know that one of the things we can do is that we can do R1 equals to R times X R1 should be equals to 1. So this is X, what is 7 over 5 equals to 1. So X equals to 5 over 7. So the transformation for R1 equals to 5 over 7, the R1 code. So with this now, we will have to perform this transformation for the new value of R1 for the O1. So O1 transformation. So if we are going to transform O1, so we now have, of course, we have R11 to be equals to 1, R12 equals to 0 to be 0, R13 equals to 5 over 7 times 1. So this, then R14. So R14 would be equals to 4 over 5, which is minus 4 over 5 times 5 over 7. This is minus 4 over 7. So, so R15 equals to 14 over 5 times 5 over 7 equals to, I think we already calculated that with the gain. So, I think so. Okay, let me check. So, so with that now, if we transform that, so we're going to have a new table with new values of R1 slotted. So let me let me just make it simple like this. So the table is going to look like this: X, Y, S1, S2, Z, decay. So 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 okay. So the new value of R1, let's just slot it in here. So this is 1, 0, 5 over 7. This is minus minus 4 over 7. So this is, no, let's do 2. 1, 2, 3, 4. Where is 4? 4. 5. 5 is 2. Then the K, so it should be set. So let me cross check. So Z here is supposed to be minus 4 over 5. Z here is supposed to be 0. R1, 1, 2, 3, 4, 5. R1 5 equals to be 0. Then R1 6 should be 14 over 5. So this is R1 6. So this is 0. So this is 2. So if you do that, we already know this is. So for row 2, what do we have? So we already have value for row 2, which is 2 over 5, 0. No, no, no. So this is, sorry, this is 1. So this is, so this is 1, 0, 1 over 5, 0, and this is still 19 over 5, I think. So, well, for Z, I think what the last value of Z that we put. So minus 4 over 5, 0, 0, minus 4 over 5, 0, 0, 3 over 5, 1. So this is 3 over 5, 1. Then this, I think I still remember this. This is 57. So this is now 57 over 5. So now that we have this, we need to use the row 1 to transform row 2 and row 3 such that the value of the, such that this, so that this and this will be equals to 0. So we can use this to transform this to be equals to 0. So, and how do we do that? So we already know, so if we want that to be equals to 0, so we need to go to transformation. So we know that for row 2 to be equals to 0, for this element in row 2 to be equals to 0, we have to do the current value. So what we want is 0. So this is 0 equals to the, the current value plus, so plus x over 1 equals to 0. So so we can just say x, our 1 is 1 already, so x times 1 equals to 2 over 5 minus 2 over 5. So x equals to minus 2 over 5. So if x is equal to minus 2 over 5, so the transformation we are looking for r equals to r 2 old minus 2 over 5 r 1. So this is the transformation we need for this. And if you look clearly, in similar vein, row 3 transformation would be, so the transformation for row 3 will be r3 equals to r3 old plus, this is now going to be plus, so so this is going to be, so this will be the relation. So because if you follow the same footstep here, we have minus here plus x times 1, x minus this, then this minus goes to the side, it becomes plus 4 over 5 r1. So this is transformation for 3. Now that we know this transformation, we can just compute what the value will be. So with this now, what do we know? So with this, we can just compute. So we can just say um, R21 equals to 0, of course. R21 equals to 0. So R21 equals to 0. R22 equals to 1. R23 equals to, so this will be 0 minus 2 over 5 times 5 over 7 equals to minus 2 over 7. So R24 equals to 0. R35 equals to 19 over 5 times 5 over sorry times 2 over 5 times 2, 19 over 5, so minus, this is minus, sorry, minus 4 over 5, 15 over 5, which is equals to 3. Okay, so those are the values for the new row 2. Then let me zoom up a little bit. So for row 3, so for row 3, so for row 3 values, so we already have the transformation. So the old value, which is minus 4 over 5, so R, so this is R31 equals to minus 4 over 5 minus, no, sorry, plus 1 equals to 0. So R32 equals to, the R32, we have to try and check. R32 equals to 0 by default. We don't need to do any calculation on that. R33 equals to, R33 equals to 0, 0 plus 4 over 5 into bracket the value of R3 of R1, which is 5 over 7. So this consistent, this is 4 over 7. So R34 equals to R34 minus 4 over 7 minus 4 over 7, 3 over 5. So we have 3 over 5 plus 4 over 5 plus 4 over 7. Am I right? Minus 4 over 7. So how do we compute this, right? So this is 3 over 5 plus minus 16 over 35, right? So this is, when we take 35 here, this is 21 minus 16. This is 5 over 7. So R35 equals to 0 equals to 1 equals to 1. R36 R36 equals to 57 over 5. So we can say 57 over 5 my plus 4 over 5 into bracket. What's the value of 1? Which is 2. So this is 57 over 5 plus 8 over 5, which is 63, I guess. No, it's 65, sorry, over 5, which is 13. So with this now, we now have to generate a new table. So if we are to generate a new table and put in the values, so we have x, y, s1, s2, z, then we have the k again. So, 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 so this, this, this. Now, so let's put in the values of x that we, our x is not changing already. So we have 1, 1, 0, 1, 0, 5 over 7, right? 1, 0, 1, 0, 5 over 7 minus 4 over 7. This is 1, 0, 5 over 7 minus 4 over 7. Z, what is Z doing here? Z is 0 and 2. 2. Then this is 0, 1. Well, let's check for in terms of 2, 0, 1 minus 2 over 7, 0. This is minus 2 over 7, 0. This is this is R2, 1, 2. So 4. Let's look at this. So I need to fill Z. Z is, I think, 0, 1, 2, 3, 4. Then I'm trying to find 1, 2, 3, 4, 5. Okay. Out to 5, which is the 19 over 5. So this is 0. Z is 0. Shimolo, did I use the 1 over 5? So this is, I think, out to 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6. So I did for 1. I did for R2 1, R2 2, which is 1, R2 3, R2 3. What is R2 3? That's based on the transformation I did. That would be 0 minus 5 over 7. This minus 2 over 7, I did that. Then R2 4. That's the one that has to do with 1 over 5. Did I do that? So this one, according to this transformation, this will be R2 old, which is going to be, so should be this should be 5 with 2. This should be 2, 3. It should be 1, 2, 3, 4, 5, 6. Should be 6. This should be 1, 2, 3, 4. So let me find with 1, 2, 3, 4. Where is the 4? 2, 3, 4. 1 over 5 minus, so that should be 1 over 5 minus R1. What is R1 at that time? Minus 2 over 5 times R1. What is R1 at that time? R1 was minus 4 over 7. Minus 4 over 7. So this is it. So this is this is this is 1 over 5 plus 8 over 35, right? So this is 35. 5 here, 7 plus 8. This is 15 over 35. 5 here, 3. 5 here, 7. So this is 3 over 7. So this R2 4 should be equal to 3 over 7. R2 5 should be 0, and R2 6 should be R2 5 should be 0, and R2 6 should be this. So this is correct. Then this should be R2 4, R2 5, R2 6. So that's sorted. We need, so this is 3 over 7. So this is 3 over 7. Sorry, that takes us a lot of time to correct. 3 over 7, then this is, I guess, 3, right? Yeah, it's 3. According to here, it's 3. So it's 3, according to here. So now let's fill for 3. Sorry, that took me a while. So 3 is 0, 4 over 7. So it's 0, 4 over 7, 5 over 7. No, it shouldn't be that. So 0, 0. Sorry, let me clear it. Yes, please, I have an idea what it should look like. So this should be, so this is 0, then 4 over 7, 5 over 7, 4 over 7, 5 over 7, 113. So this will be 4 over 7, 5 over 7, 1 and 13. So according to this, we have succeeded in transforming this into 1001, and this is 0. And according to what we are looking for using, so let me try to zoom this so that I can write a pretty conclusion. So in conclusion, so conclusion, so we are going to x equals to 2, y equals to 3, and z equals to 13 as the optimized solutions that maximize z. So that's it. So let me just go a little bit recap. So from the beginning, the goal of this work is to find a way to solve this problem, which is simplex method to maximize z equals to 2x plus 3y, subject to this constraint. And we did that. We did the transformation. We got the table. We got the rows. Then we did the transformation up to this point that we got here. So that's it. Thank you.